So we were doing this app that was using generative AI, and it was not working very well. It's not very accurate.
So it was hallucinating.
Yes, exactly. So we're going to show you how we managed to fix this problem, and you're going to explain how it works behind the scenes.
I will try.
Yeah, my name is Tiffany.
My name is Mike. So Tiffany, can you tell us a little bit more about this application that you were developing?
Yes, so the app is basically an app to, you give your persona, basically if you're a developer, if you're a solution architect, or whatever profile you have, and you talk about the different technologies you want to use. Basically, if you use, like, let's say Python, Java, and what do you want to learn on AWS services, like let's say you want to learn more about containers, and what the app is doing, at least the idea was that the app would give you a learning path of the things that you need to search for in order to, like what would be interesting for you to learn on AWS, basically.
Absolutely. So I can go to this app, I can tap buttons and say, I'm a Python developer and I don't care about anything else. And, and hopefully it can help me to figure out what I need to learn next.
And like historically how you would do this is that you would create for each combination of answers a customized path, but then, it's hard to maintain this kind of application because you need to make sure that first you get all of the different combinations right, and then you need to make sure that your app is up to date with all of the different services that is out. And we know that at AWS we have a lot of services coming out all the time. So it was an app that was, at first we thought it was simple to make, but then when you think about it, we're like, maybe Gen AI can help us make it, make it easy for us as developers.
So how did you use generative AI to help?
So the approach basically at the beginning was very naive. We were like, oh, it's just, have an LLM, like a foundation model, and plug it to the app, and let's see what it returns as an answer. And basically, like, we had, so this was very easy to do because we just had to call an API. And we got answers, but the answers were, as I said, not very accurate. And also, sometimes it was not very, specialized to around AWS services. So we wanted to make sure that first it was not hallucinating, because sometimes it was trying to give us answers, but it was not the right thing to answer to someone. And then also we wanted to make sure that everything was up to date.
Yeah.
So we used something called Amazon Bedrock. And it was very easy to use. Like, I actually built it very quickly on the console. And basically, what I was using was a knowledge base.
Right. Yes. So Bedrock, I guess, managed service, which gives you access to lots of different foundation models.
Yes.
And inside of that, knowledge base, which is the solution that you used for this application.
Yeah. So the knowledge base, I didn't know anything about knowledge base before, but from my understanding, what it did is that it was helping me customize my foundation model specifically to a certain task. And the only thing that I needed to do was to give the model additional information, data that was specific to my use case. So the first thing that I did was, what I need is all of the information about the AWS products. So I scrapped all of the...
Scraped.
Sorry,
You don't scrap our products. You don't. Scraped it. That's good.
I scraped all of the HTML pages of our products, and I only had to put the HTML pages in an S3 bucket. And then I gave Amazon Bedrock the URL to my S3 bucket, and suddenly everything started working well. And so my question for you, Mike, is how does it work behind the scenes? Like, what's happening there?
Yes, look, it's really good to hear that working. I guess the initial problem you were having is just by plugging in the application into a large language model, it's only got access to the knowledge, if you like, or the information that it had when it trained. So it might not have been trained specifically on AWS, for example, and so it would provide answers that looked like they were probably right statistically, but may not have actually been accurate. So that's the hallucination part. So what you've done there is you've used knowledge base, which is implementing retrieval augmented generation, or RAG, And that is a way, as you say, to sort of customize your application to give it access to current information and to your information quickly and easily without having to do things like fine-tuning or retraining the model. We can talk about how this is actually working. What it's actually doing is it's creating a vector database in the background which contains your documents, and then you use that and use the ability to search that to augment, so retrieval augmented generation, to augment that generation that you've created and the prompt that you send in. So it's pretty interesting. It's very easy to do with knowledge base. What I'd like to do here is show you this code. That this code is actually doing the same thing in a really simplified way, just to sort of give you a sense of what's happening underneath the covers of this.
Okay.
I've got here a Jupyter notebook where I've just thrown some code in here, and let's run through each of the cells and you can sort of see what's happening. The first thing I'm doing here is just with most Python code, I'm just importing some libraries. So let's just get that done, and then we'll look at the different libraries that we're using as we step through the code. I'm going to create here myself a Bedrock runtime client. Now, I don't want to get too confused here. So you've used the Bedrock knowledge base.
Yes.
This is a part of the service there to help you easily create all of this without having to step all of this code through this code. I'm using the Bedrock runtime client here to get access to embeddings models and also large language models right here in the notebook. So I create that client for me now, which I can then go ahead and use elsewhere in this code. So now that I've done that, the setup is ready. We can get into the similar kind of scenario that you are working on. Now, I've created this very simplified version here where I've got a list of facts. Now, these facts are just facts about the solar system. Hopefully, they're broadly correct. That's not the point of this. And this sort of represents my knowledge base. This represents the documents that I might have got. So for you, this was all of the information you're able to download about the different AWS services. For me, it's simple sentences about the solar system. So I've got these facts, and they're here inside of this list. So it's very simple. This is a very small scale demo. So there, I've got those created now. Now, what I can do is, in the same way that you did with knowledge base, which was basically to point it to the S3 bucket with all your data, and it then created in the back end this sort of magical resource which made everything work. We're going to do that here in code. So what we need to do is we need to create ourselves an embeddings index, which has got all of that data stored inside it. So we can do that here by using Bedrock. There's multiple different foundation models available in Bedrock. There's not just the large language models. We also have embeddings models. So these models that can take text and convert them into embeddings that you can use for things like this search that we're going to do here. So I'm going to define this function here that I created, which will help us to use the Titan embeddings model, which is Amazon's own embeddings model. And once we've got that defined and wrapped up into this little function, we can use this, we can pass it in strings, we can get our embeddings out. So the next thing I have down here, and the next cell I have here, is to basically run through all of those with that function and create all of our embeddings for us. And those embeddings, what are we going to do with those? So we need to put those into a special kind of data store, a vector data store. Now we're just using this open source, I think Face, never actually said it out loud before. It's an in-memory vector store that we can use just inside of this notebook. So I'm just going to create that now, and that's an index that I've got which is ready to receive all of those embeddings that we've just created, and then follow along with me, guys, here. So I just press this run button here, and it's now going to basically bind those things together. So all of our embeddings are now inside of this vector store. So we've just gone through, and it took a little while, but it's very simple. That process is the equivalent of what you did, Tiffany, when you put the documents in the S3 bucket and you pointed knowledge base at it. It took a moment or two to process that data and say, yes, I'm available. That's the equivalent of what we've just done there.
Yeah.
So now let's step through how we use that and how retrieval augmented generation works. Again, no one's expecting anybody to have to code it longhand like this. There are many ways you can do it.
So basically, to sum up everything that you did here, took the data, put them in vectors, put them in vector database.
Yes.
And now, how do we query this database?
That's it. Perfect question. Thank you. Yeah. So let's have a look. So I have a question here. So what is the Milky Way? Again, super simple question based on the data set that I've got. So what we can do, and I want you to note at this point, we're not touching large language models at all. We haven't done any of that yet. We're still working with the vector database. So I can take the query that I've got, what is the Milky Way, and I can embed just that sentence. So let's go ahead and do that. And I'm going to add some code in here because I just want it to be super clear. So let's just add a quick cell in here, and we'll take a look at the embedding, the query that has been embedded. So if I just run that, you'll see what looks like this massive vector, right?
Yeah.
So it's a huge long vector, and I'm sure it's going to get truncated, right? Because it's just so big. Yeah. So that's essentially what all our data looks like. And now this is also what our query looks like as well. So we can actually now perform a similarity search. So we can basically give our search query to the database and say, find me all of the things inside of that database which are similar to our query. So in many ways, it's just like searching a database. I mean, it is searching a database. It's just using this vector search space, this cosine similarity, or whatever kind of search that we're doing to try and find things that are similar to our query. Again, no LLMs yet. So that's what this code does here. And this K at the end here, which we're setting to a value of 4, basically says, bring back the 4 most relevant facts from your database, which relate to the query in this case, which is what is the Milky Way. And so if I run this, I've got a couple of things which I'm printing out from here. The first is this list of indexes. So these are the actual index values
of the vectors.
Of the vectors, exactly, which will match to our original list of facts. So fact number, I guess, for the 0 index, that's 15 and 14, and the first one and the 12th one, will be the facts that contain the information that we're looking to get. And we also have from here the distance inside of the vector space. So this fact here, the first one, is very likely to contain the actual answer we want. Again, super simple demo. It actually does contain the answer. So that's what we've got. And all we now need to do is sort of work our way back from there. Now, all we've done up to this point is the retrieval part of retrieval augmented generation. What we now need to do is take the answer that we have there, so the actual text string, or in this case, the 4 text strings that we've got, provide that to a large language model and say, okay, this was the original question. Here is some data. Figure out the actual answer.
Here is some data related to that question. So it's not even like it's looking at all of the data in the database. It's actually looking at the most relevant data in the database.
That's right. So the retrieval got the most relevant data, absolutely. And now we're going to put that into a prompt. So we're actually putting the data into the prompt. It's in context learning. We're providing the data at the prompt level, not at the original training data level. So we can see that happening here. So I've got here a prompt template. And so I say, and I'm using Claude V2 through Bedrock, through Amazon Bedrock, and it says human, which is the human, human assistant syntax. Yeah, so I'd say, so given the facts provided in the following list of facts, between the facts tags, find the answer to the question written between the question tags. It's prompt engineering stuff. And so then we list out, and I'm using the Ginger templating language to be able to do that. So we then insert the facts here, and then we say, okay, basically now go figure out the answer. We also say, given the if it doesn't know the answer, if it can't figure out the answer, then don't pretend, don't hallucinate.
Don't hallucinate.
Exactly. Say, given the information I have access to, I'm unable to answer that question. So let's load up that template and move forward. We use Ginger here to actually build that template up. And again, I'm just going to actually show what that prompt looks like now that it's all been filled out. And it should be pretty much as you imagine. It's all on one great big long line. Let me print it instead. That will be better, right? And if I do that, there we go. Okay, so now we can see it properly. So here is the template as we saw with the facts added in. So those are the 4 relevant facts that we retrieved, and we've now augmented our prompt, and now we can send this prompt off for generation.
Just before we saw them as vectors,
Yes.
Now we see them as words.
That's right. So the vectors that we get out of the vector database get converted back. Well, converted back to words isn't true. Sorry. They get. We look up the original document that related to that vector, because vectors are a one-way calculation, and we put that in here. And so hopefully we've got the right answers in here. Although I noticed that the last one actually, so I think that it's a similarity score that we had above. This one is probably the most likely answer.
Yes.
Let's see what happens.
That's the exact answer to the question.
Yes, it is. Very simple solution here. So let's go ahead and send this in. So now, this is the first time we've done anything to do with large language models. Now we're going to send that prompt into Claude V2.
So everything that we did before was the RAG, basically.
It was the vector side of stuff. Yeah, exactly. Yeah. Well, it was the RA, the retrieval. Then we augmented. Now we're doing the generation. Yeah, exactly. So we've just done that. We'll run through our standard code that we used with Amazon Bedrock services, and we should get an answer at the bottom.
Yeah, exactly.
The Milky Way is a galaxy estimated to contain 100 to 400 billion stars.
Yeah.
Easy.
Yeah.
So the thing that I wanted to show here is how there are two separate entities. You've got your vector database, which is storing all of your vectorized data. You've got your large language model. They work together in your application, but they are separate things. And under the hood, that's how RAG works.
And so it's really cool, but then you don't, if you're a developer and you want to build your app with Gen AI, you don't necessarily have to do all of those steps yourself, right? This is why we have frameworks like Bedrock that are fully managed.
Yes.
And actually, like I said, I didn't do much for my application. I just retrieved the data, put them in an S3 bucket, and then
magic happens.
Yeah, and magic happens because everything that you just explained is actually what Bedrock is taking care of.
Yes.
Behind the scenes.
Yeah, and so as you're working with those services and you see some of the settings which are available, having a sense of how it actually works helps you to be able to figure out where you might need to tweak something to get the performance working a little bit better.
Exactly.
And stuff. You can also use things like LangChain. So LangChain is an open source prompt engineering framework, basically. You can use that with Amazon Bedrock too, with other large language models, with vector databases. You can create generative applications that way as well. Many different ways to do it. Lots of open source projects doing this kind of thing as well.
Yeah.
It is amazingly exciting. And as you saw, it gets you those accurate results from a generative AI application, but without having to go to the expense of training your own specific model.
Yeah, and as you said also, which is, I think, really cool with this app, is that to maintain information up to date, I only need to retrieve the data from the web pages and put them in my bucket, my S3 bucket. And then everything behind, like everything that Bedrock does or would LangChain do also, is to take care of the new information and put them in the vector database, and there you go. You have all of your information up to date. Absolutely. So that's really good without having to fine-tune your model and everything. So
that's absolutely. I'm really looking forward to see how much this is going to get used, specifically next year as well. I think this is the sort of frontier of where a lot of people in the real world using generative AI, this is where a lot of the value is. So
awesome.
Very exciting.
Thank you very much for the explanation.
No worries at all. And if you want more information about this kind of thing, then head over to the community.aws website. The link will be in the description below. Look for the generative AI space, where we've got articles on this and many other things.
And if you like the video, please give it a like and subscribe, and see you next time.
Bye.